With me today is Jon Cassell from Omdia. Welcome, Jon. Tell me what you do at Omdia.
Well, I'm a principal analyst covering artificial intelligence and Internet of Things for the advanced computing information service at the company. In practical terms, that means I cover artificial intelligence chips and systems with a specialty on the cloud and data center.
I wonder if you could talk a bit about hardware and software co-design?
Yes, that's been a very much of a hot topic out in the design world, particularly with the rise of artificial intelligence in the area. What it is which is what it sounds like. It's the co and parallel development of hardware and software solutions. And typically you find this being used in system-on-chip devices that are commonly deployed in embedded systems.
So why is that important?
Well, increasingly chips are becoming very complex, and it's becoming increasingly important to understand how well they'll actually operate when they're out there in the field. So what you can do by co-developing the hardware and software at the same time is, before you actually develop a physical implementation of the chip, you can develop a very good idea of how it works with software. And particularly in the artificial intelligence area, where workload optimized types of tasks are becoming more prominent, it's good to know how well your software is working with your hardware, and to figure that out very early in the process, as opposed to later when it's more expensive to iron out problems.
So what's the state today of that implementation?
Well, we see companies like Cadence, an EDA company, offers these large, expensive and rack-mounted systems that can perform virtual prototyping very early in the chip design process. And this allows you basically to simulate the chip and then simulate the software running on it to see how well it goes. And that allows designers to understand how well it's working, if it's working at all, and to make changes both on the hardware and software side to make things work better.
So it sounds like there might be some other implications wider for this kind of design?
Yes, in addition to helping to design better, more workload optimized chips, particularly AI chips, what we see here is that this kind of technology involved in virtual prototyping is leading to what you might call a culture of simulation. There's a company out there that you may have heard of, NVIDIA, and what they're leading in the AI area. And one thing they're using is they're making extensive use of this virtual kind of prototyping technology, but they saw it as being inspirational for a wider trend towards what might call the metaverse, which is a simulation of reality, combining kind of immersive, interactive kinds of views of the real world, combined with simulation with data from the internet, etc. And you can use this to simulate all kinds of things, from a molecule to a factory to the entire world. And these systems are coming into increasing play from companies that want to simulate real systems such as factories and determine what would happen, say, if you made a change to the factory floor, how it would affect productivity, how it would affect output, and other things like that, all the way to major systems and determining what will happen on the factory floor if you change them. So this has quite a few implications out there for the wider world, I think, as we move towards a world that more embraces the metaverse, digital twins, increasingly using simulations to gain a better understanding of the world around us and make things more efficient.
It sounds like what you're talking about is even beyond digital twins in terms of like what NVIDIA is doing, so forth.
Yes, this technology has a lot of potential. I think over time you're going to see larger, more complex systems becoming simulated in this fashion, and I think there's a lot of implications for everyday users and things like that, from everything from productivity to efficiency to safety, that will come along as a matter of using these kind of metaverse technologies.
So you live in the world of chips. What excites you? What do you see coming?
Well, I see a future world where chips are far more powerful and capable of handling real-world simulations and using artificial intelligence capabilities to do these kinds of things. So I think we have a lot of potential out there of real developments in that area, where chips are becoming much smarter, much more capable of simulating the real world as it is, and providing a simulated experience that improves life for people all over the world.
Did you ever expect we'd be here at this stage?
For a long time, artificial intelligence was the technology of the future and always would be. It was the technology that had a lot of potential, but really there was not the capability on the chip side to support it. But over the past decade or so, we've really seen a lot of developments. It's turned out that graphical processing units turned out to be an excellent platform for running AI, and has led to the introduction of AI and usage of AI services by the cloud, and now moving out to the edge. But now we see that there's a lot of possibility beyond the GPU of specialized chip architectures that can be used to accelerate AI and really bring it to people's everyday lives, to companies, to consumers, to everyone. And I think that the developments in chip technology are really what's making the current AI revolution possible, and what will enable future developments in this area.
So do you see any wall ahead where the industry just says, we can't pass this? Do you see anything like that coming, or does it just keep going?
There are plenty of big obstacles out there in the market. As I previously mentioned, we see the growth of AI model sizes, and it's really taxing the capability of semiconductors to keep up, and it's causing power consumption issues where we see data centers, hyperscale data operations really using tremendous amount of power, and may exceed the capability of society to supply them. So that could be an obstacle out there, but I think that the technical capabilities of the tech industry are more than capable of meeting this challenge. I think we're going to see more efficient chips, more efficient approaches to AI coming out that are going to allow us to bypass these challenges and continue the development we've seen in this market.
In relation to the land of chips, what does Omdia present to the marketplace in terms of benefit?
Well, Omdia has an unparalleled set of programs and expertise covering the AI area, not just the chips and the hardware side, which I represent, but we also have people tracking the software area, developments in that, services, and various hot developments in the market. So we bring together a holistic view that really connects the dots of the AI area and provides a complete view of the market. So anyone addressing the area really needs to have a comprehensive view of the market, not just chips, not just hardware, but needs to understand software, services, other dynamics that are impacting the market. And the group that I represent really brings the whole package to the table.
It sounds like you represent the ecosystem.
Yes, very much so. We've got it covered. From chips to systems to software. We've got the whole thing in hand.
Thank you so much.
Thank you.